Dear students, good morning. Today we start third unit. Third unit has two parts: transportation problem and assignment problem. First, we look into transportation problem. My lecture outline today will be like this. First, we have to introduce transportation problem. What do you mean by a transportation problem? And then its mathematical formulation. Then how a transportation problem be given in a transportation table. Then solution of a transportation problem. Then we will see one of the methods of finding initial solutions of a transportation problem known as Vogels approximation method, otherwise VAM. Then we will fully work out an example for VAM. Then finally, review questions and exercises for you. Transportation problem. What is meant by a transportation problem? It is a particular kind of linear programming problem in which the objective is to minimize the total transportation cost of a particular commodity from a number of sources to a number of destinations. Solutions of the transportation model requires to find how many units of a particular commodity should be transported from each origin to each destination in order to satisfy all demands while minimizing the total cost of transportation. And this is the mathematical formulation of a typical transportation problem. Here we have certain assumptions. Let us assume that there are m number of sources and n number of destinations. The sources will have some supplies. Let A1, A2, A3, etc., AM be the supplies at the sources, and let B1, B2, B3, etc., Bn be the demands at the destinations. Let us assume that Cij be the unit transportation cost from the particular source I to the destination J, and let Xij be the number of units to be transported from source I to destination J. On these assumptions, a transportation problem can be given mathematically as minimize z is equal to sigma I equal to 1 to m, sigma j equal to 1 to n, Cij into Xij, subject to the constraints sigma j equal to 1 to n Xij equal to ai for I equal to 1 to m, sigma I equal to 1 to m Xij equal to bj for j equal to 1 to n, and the number of units are always non-negative, that is Xij greater than 0 for all I equal to 1 to m and j equal to 1 to m. But when we do a problem, it will be given as a table. So all the components can be put into a table which is known as transportation table. It is a rectangular matrix having certain rows and certain columns. Rows mention origins and columns denote destinations. We shall assume here there are m number of origins or sources, say O1, O2, O3, etc., OM, at which the supplies are listed to be A1, A2, A3, etc., AM. Let us assume there are n number of destinations, say D1, D2, D3, etc. Dn, where the demands are denoted as B1, B2, B3, etc. Bn. First of all, before solving this problem, we need to check whether the total supply is equal to total demand. That is, sigma I equal to 1 to m ai should be equal to sigma j equal to 1 to n bj. If these two summations are equal, we say the given transportation problem is a balanced transportation problem. Otherwise, it is unbalanced. Any transportation algorithm to solve the given transportation problem can be used only for balanced problems. So, if the given problem is unbalanced one, we have to make it into a balanced one. We will see this later. Now, we will move on to find the solution of a given transportation problem. The solution part contains two phases. One is to find the initial solution and then to find the optimal solution. To find the initial solution of a TP, there are three methods. The first method is northwest corner rule. Coining the first alphabets of northwest corner rule, we can write NWCR, northwest corner rule or northwest corner method. We usually say the northwest corner rule NWCR. The second method is least cost method, or we can write it as LCM. This is also called as matrix minima method, triple M, MMM, matrix minima method. And then the last one is Vogel's approximation method or Vogels method or VAM. After using any one of these three methods to find the initial solution of the transportation problem, that solution need to be checked whether it is optimum or not. That is, otherwise it's a test for optimality. Test for optimality is done by a method known as modified distribution method or MODI method. The first two letters of modified is MO and the first two alphabets of distribution is DI, MO, DI, MODI or MODI method. The purpose of MODI method is to find the optimum solution. First it checks whether the solution given by initial method is itself optimum, otherwise it will modify the distribution so as to get the optimum solution. We shall see here Vogel's approximation method. This method is usually preferred over NWCR or LCM because the initial feasible solution obtained by Vogel method is either itself optimal or it is very close to the optimal solution. So normally one would go with Vogel method instead of northwest corner rule or least cost method unless otherwise given. There are three steps roughly explained. Step 1, first look for each row, look for the least and next least element, find the difference that is said to be row penalty. So find row penalties for each row. Similarly, find row penalties for each column, that is column wise. You look for first column, second column, third column, etc. For example, first column. In the first column, observe which is least one and next least one. Find the difference, you mention it down. So that will give column penalties. So there are certain row penalties and there are certain column penalties. Totally, there will be a finite number of penalties. In step 2, identify the row or column with the largest penalty. Then allocate minimum supply or demand, whatever it is. If supply is minimum, you take the unit, or if demand is minimum, you take that much number of units in the cell with minimum cost. Then, if a particular cell is allocated with a minimum of supply or demand, suppose if supply is the minimum one, then all supplies will be cancelled out, that is exhausted, and in the demand, this total supply will be, that supply will be cancelled to write the balance of that. Suppose for example, second row is selected. In the second row, the supply is 200 for a particular cell in the second row. Say for example, in the second row, the first cell. So in the first cell down, we have a demand. Say for example 300, supply is 200, demand is 300. So 200 will be, the supply will be fully exhausted. We can cancel out. In the demand, 300 minus 200, only 100 will be remaining. We have to strike out 200. So if 200 is 300 minus 200 will be 100 only. So it is the first, for the first set of values, the procedure is over. Repeat this process again and again until all the supplies and all the demands are fully exhausted. We will explain this by looking into a numerical example. So here it is a TP with the 3 rows and 4 columns. There are 3 origins or 3 sources and 4 destinations, D1, D2, D3, D4. Supplies at origins are listed as 300, 400, 500, and demands at the destinations are listed as 250, 350, 400, 200 in the bottom of the table. First, we need to check whether the total supply is equal to total demand. Total supply is here 300 plus 400 plus 500, that is 1200. Total demand is also 1200. So the problem is a balanced one. We can attempt Vogel method to this problem. How to do Vogel's method? First, look into the first row. The cost in the first row are 3174, which is minimum cost 1, which occurs at the second row first column element. Intersection of O1 and D2, we have the minimum cost as 1, next minimum is 3 at 1 cell. So difference between these two is modulus of 3 minus 1 or 1 minus 3, whatever it is 2 difference. Right in the row difference, there is number 2. Similarly, do it for the same other rows, 2, 3, 1. That is row differences. Now we come to determine the minimum and next minimum, the differences between those two column wise. The first column, it is minimum is 2, next minimum is 3, difference is 1. Similarly, we have the other differences 2, 2, 2. There are 7 penalties or differences. Out of these penalties, which is the maximum one? Maximum one occurs at the second row as 3, number 3. So, second row to be allocated. In the second row, there are 4 cells. Which cell is to be allocated first? For that, you go for the minimum cost cell. Cell 2, 1. That is in the second row, the first cell. Overall matrix, it is second row, first column cell, that is 2, 1 cell, which has a minimum cost of 2 to transport. So that cell is to be allocated with as much units as possible. What is meant by that? Corresponding to second row, first column, we have in the bottom 250 demand and the right hand side 400 as supply. Minimum is what? 250. So 250 should be allotted there. If it allot 250, 250 will be exhausted in the bottom demand fully. Demand is exhausted at D1. and O2 400 minus 250, 150 units will be remaining in the origin true. Then we have to strike out the first column fully because it is the demand at D1 is satisfied. We can strike out first column. Then repeat the procedure. After striking out the first column, the remaining matrix will be of 3 by 3. So for the 3 by 3 reduced matrix, we do the same procedure. There will be 6 number of penalties. That is 3, 1, 1, 2, 2, 2. Out of these 6 penalties, 3 is the maximum one. Select first column. In the first column, 1 is the minimum cost. Allocate at that cell minimum of supply or demand. That is 300 is supply is the minimum one. 300 allocate 300. Cancel out 300 fully. In the bottom, we have 350 as demand. 350 minus 300, 50 will be remaining. Now, because the supply at O1 300 units are fully exhausted, we can strike out the first column also. So the remaining matrix will be a 2 by 3 matrix, 2 rows and 3 columns. Repeat the same procedure of finding the penalties and allocating in the minimum cost cell again and again. We have finally this matrix fully. See, it is here we look into that. There are 6 number of allocations 300, 250, 150, 550, 250, 200. That should be equal to m plus n minus 1. M is number of rows, n is number of columns. So 3 rows, 4 columns, m plus n 3 plus 4 is 7, minus 1, 6, 6 number of allocations over. So the solution is a feasible solution, that is acceptable one. Then how to compute the transportation cost? We have to multiply the particular allocations with the corresponding costs. So 300 into 1. Then for the second row, 250 into 2 plus 150 into 5 plus 50 into 3 plus 250 into 3 plus 200 into 2. That comes out as rupees 2850. So this is the solution suggested by Vogel approximation method, which is only initial solution. We need to check using modified distribution method whether the solution provided by Vogel approximation method is optimal or it has to be modified. We will see this modified Euler's method in some other hour. Now we shall see an example for an unbalanced transportation problem. As I have already said, an unbalanced TP is one in which total supply is not equal to total demand. But to use northwest corner rule, whatever it is, any solution method, either initial or final method for a transportation problem, the given transportation problem should be balanced one. So we have to make this unbalanced transportation problem into a balanced one. Here, looking into the table, total supply is given to be 117. Already they have itself given that it is 117. We can add up also. If we add up all the supplies, we will arrive at 117. Similarly, total demand is 95. So which is not equal. So 117 minus 95, that is 22. 22 units surplus at the supply, or 22 units deficient at the demand. So we have to add a dummy column, say D6, with the zero costs, all the costs to 4 costs to be zero, with that 22. Yes, deficient demand should be written. Initially, the given problem is unbalanced one with 4 rows and 5 columns. To make it balanced, introduce a dummy column D6 with 22 as demand to make the problem into 4 rows 6 column matrix. And then here now it is 117, 117, both are rows and columns are equal. Then we can, as usual, proceed with the Vogel's method or any other method also. Okay. Now there are certain review questions for you. You can answer these questions. What is unbalanced transportation problem? What is degeneracy? You can define feasible and optimal solution, and you can solve certain problems using Vogel method. A, a sufficient number of exercises are provided here. You try out there in your home. There are three problems I have given to you. Look at the second problem. It is only two rows and three columns, but total supply is here 10 plus 20 30, whereas total demand is 20 plus 20 plus 20 60. They are not equal, so it is an unbalanced problem. You make it first balanced and then try for Vogel method. Okay, and third one is already balanced. You can go for the Vogel method also. Okay, that's all. Thank you.